Hello everyone, my name is Muhammad Awais and welcome to this demonstration of my machine learning project, the Age of Death Predictor. This tool uses a random forest regressive model to estimate life expectancy based on various health, social, and economic factors. So let's dive into how it works and how I built it. I used several libraries throughout the project, such as pandas for managing and analyzing the data, matplot and seaborn for creating detailed visualizations, scikit-learn for splitting the data, training the model, and evaluating its performance, Gradio for building the graphical interface to make predictions accessible to everyone. Moving on, then I loaded the dataset into Python using pandas, a powerful library for data analysis and manipulation. The dataset contains features like country status, adult mortality, alcohol consumption, BMI, and more. All of them are crucial factors that influence life expectancy. Next, I cleaned the dataset to ensure reliable predictions. This involved handling missing values, outliers, and converting categorical data like country status into numerical format for machine learning. Moving on to data visualization, I used matplotlib and seaborn for visualization, and I visualized the data to understand patterns and relationships. For example, I created correlation heat map and scatter plot to identify which features most strongly influence life expectancy. I used scikit-learn's train test split function to divide the data into training and testing sets. The training data helps the model learn while the testing data evaluates its performance on unseen inputs. Next, we move to model training. For model training, I chose the random forest regressive, a robust algorithm that combines multiple decision trees for accurate predictions. It handles non-linear relationships and prevents overfitting effectively. Model testing. After I was done training the model, I tested it using the testing dataset to check its accuracy. I predicted life expectancy for unseen inputs and compared these predictions with actual values from the dataset. Then evaluating the model. For this, I used metrics like mean squared error and R-squared score to evaluate the model's performance. The results indicated that the random forest regressor provided reliable and consistent predictions. Predicted line graph. I also visualized the predictions using line graphs. These graphs compare predicted values against actual ones, helping to validate the model's accuracy and highlight any discrepancies. And let's move to the interface at the end. I developed the user interface using Gradio, making it interactive and user-friendly. So let's walk through the interface. At the top, we have the title and a descriptive image to set the theme. The input fields let you provide values like country status, adult mortality, BMI, GDP, and more. You can use the sliders and drop down to make it simple and intuitive. Once the inputs are set, clicking the predict button displays the predictive life expectancy in the output below. Let's demonstrate the interface. I'll start by selecting the country status as developed and set the BMI value of let's say 25, and the other factors like let's go with alcohol consumption, schooling, BMI, and all. Okay, now I'll hit the predict button, and here you go. The model provides an estimated age of death. This wraps up the demonstration of Age of Death Predictor app. It's practical application of machine learning that combines predictive modeling with interactive design. Thank you for watching, and I would love to hear feedback from you.